Hello everyone, welcome back to our statics example problem solution series. And in this question, we are given a simple beam and we are asked to calculate and to find the reaction forces at the supports A and D. So what we have is we have a 6 kilonewton force acting here 3 meters away from support A and 6 meters away from support D. And we have an external moment which is 9 kilonewton meters acting in the counterclockwise direction. So the location of the moment is actually doesn't determine and affect the solution of our problem, because as you know, we can place this moment anywhere we want. So I just placed it at the support D. In order to find the support reactions at A and D, we need to draw the free body diagram and show the reaction forces. So we have 6 kilonewton here and we have our external moment 9 kilonewton meters here. So since we have a pin support at point A, we're going to have reactions in the both vertical and horizontal directions. So we have AY, which is the reaction force in the vertical direction, and we have AX, which is the reaction force in the horizontal direction. In addition to those, we have a reaction force at the support D, and since support D is a roller support, which you can see here, we are going to have a reaction force only in the Y direction. So the reaction force for the X direction is not available at this point. So after that, what we're going to do, we need to recall that in statics, if you are given a system, all of the forces internally in X direction, in Y direction, and sum of all of the moments acting on the system should be equal to 0. And we name those properties as the equations of equilibrium. So let's start by verifying the equilibrium in terms of moments. And for simplicity, let's take the moments with respect to point A. So I'm using this convention which says that I'm going to take the counterclockwise moments as positive. So this 9 kilonewton meters is going to have a sign of plus, while the moments created by the 6 kilonewton here is, as you can sense, it is going to act in the clockwise direction, so it will be considered as a negative moment. Let's move on. So as I said, this 6 kilonewton is going to create a negative moment. So how do we calculate the moment? It's force times distance. So minus 6 kilonewtons, and what is the distance to support A? It's 3 meters times 3 meters, and we have 9 kilonewton meters here. It is going to have a plus sign in front of it because it is acting in the counterclockwise direction. And the reaction force at the point D, which I named it as dy, is going to create a moment at point A which is acting in the counterclockwise direction. So it's going to have a plus sign in front of it. So it's 9, which is the distance from point D to point A. It's 9 meters. 9 meters times dy is equal to 0. So the forces at the point A is going to create no moment on the system because, as you know, the moment arm for the forces in A is equal to 0 since we are taking the moments with respect to point A. So when you solve this very simple equation which I showed here, we get dy as plus 1 kilonewtons. What does this plus sign means? It means that the direction I assumed here, which is upwards, is correct, and dy is actually having a magnitude of 1 kilonewton with the direction of this upwards. So in order to find the reaction forces at A, let's first consider the equilibrium in the vertical direction. So again, I'm using this sign, which means that the forces acting upwards is going to be considered as positive, and summation of all of the forces in the vertical direction should be equal to 0. So AY and DY, I assume they are both acting in the upwards direction, so they are going to be both positive, and since also we know that dy is acting positive from here, and 6 kilonewton here is going to have a sign of minus because we assume upwards as positive, while 6 kilonewton is acting downwards, so it is minus 6 kilonewtons. And when we solve this very simple equation, we get the reaction force at point A in terms of the vertical force as 5 kilonewtons. Again, we got it as positive, which means that the direction we have assumed at the beginning is correct. One last equilibrium equation that we need to consider to find the reaction force AX is the equilibrium in the horizontal direction. So from this very simple free body diagram, you are going to observe that the AX is 0 because there is no external force acting in the horizontal direction in our system. So this will result in no reaction force in the X direction. So we are going to take AX as 0 kilonewtons in this question.